welcome to the session. So today I'm going to talk about SQL versus NoSQL. So first of all, we will learn, what is SQL database, right? So I'm assuming that most of you guys know what is SQL. Right? SQL stands for Structured Query Language, and mostly whenever we say SQL, we refer, RDBMS, right? So it's a relational database management system. The SQL is in a general world is a synonymous for RDBMS, right? So it basically relational database. And can someone give me some examples for the relational databases like RDBMS? I hope these databases are covered in your syllabus in one or the other semester. You can give me one or two examples of RDBMS, which is basically SQL DB. No one? Sorry, there's a lot of background noise. I couldn't capture that.
Any company or college database?
Okay, but technology-wise, is it okay? Let me give an example, and you let me know whether it is RDBMS or not. So Oracle DB. So is it RDBMS or it's a NoSQL database? Oracle database, MySQL database. Right? These are the databases provided by different organizations. Correct. Oracle is provided by, of course, Oracle, and MySQL is a open source database. PostgreSQL, MS SQL Server. Right. So these are okay. I think many of you might have joined mobile, and it might be difficult to communicate. Understand that. So I'll proceed further with the topics. So just to cover that point, all the databases that I have mentioned so far, all are RDBMS, right? The MS SQL Server, the Oracle, MySQL, PostgreSQL, all these databases are classified as RDBMS. Means these databases are designed for for relational data, right? They meant for relational data. The technology is designed in a way such that different relationship between the entities can easily be created and maintained, right? So that's the whole purpose of having such kind of database. The SQL, when we say SQL DB, it is fairly synonymous to that. And as far as I know, in the colleges, all the time they teach is about RDBMS, right? So now, I'm not sure whether how many of you have heard the name NoSQL even before this talk. So there might be like few of you who might already aware, and I'm not sure whether it is already included as part of your syllabus lately. Right. So NoSQL. Okay, before I go further, did anyone hear this before, or is it part of your syllabus or something? Okay. Yeah. So primarily, the NoSQL stands for not only SQL. It does not mean that there is no SQL. So many people tend to get confused with NoSQL terminology because they think that, okay, there is no SQL at all, right? There is no structured query at all. No, it's not like that. NoSQL means not only SQL. That means it has almost all the capabilities of your SQL database. On top of that, it also comes with its own unique features, right? And of course, there will be certain limitations on it, but still, you will get to do a lot of different things, which was traditionally not possible with the RDBMS. So when the RDBMS was the very first database that came into picture, and many of the softwares which is already there in the industry runs on that. and it's of course it's a very robust, so many applications built on it, it's running production, still people use it. But what happened lately is that as the industry grew, there are a lot and lot of data, right? So the data that the data generation that happened over the time for any organization, or because of this internet's connectivity, even it's possible that even your software is launched today, and within a month or within a year, you get to get a lot of millions and millions of data, right? And when you have such kind of data which is maintained in your database, it really becomes difficult to maintain that in a SQL database, right? Because your software is tend to evolve. So whatever the features that you develop in your software today is likely to get changed, uh, depending on the need of the customer, or depending on the how business or where it is used, right? Almost everywhere, or almost any software, it is tend to change. And whenever the change has to happen, it becomes really difficult to maintain such software in RDBMS. And not only that, as the data grows in a particular database, it becomes really challenging, even to identify any issues that comes in, and even the performance of the database drastically gets affected. And also because of this, all the boost in that internet connectivity across the world, the the regional coordinations has become smaller and smaller, right? That means there might be data which is available here. The same data also needs to be accessed, at some other location. And also you want some kind of a data guarantee where, if a particular database goes off, still you want to, for example, all your, let's think like this. All your Aadhaar card data is maintained, somewhere in some server in Chennai, or some location in India. Let's say that some earthquake happened, or some natural disaster has happened, due to which that server is gone now. Then what about the people's data which is actually got stored in that database, right? So it gets affected, not in only one application. It all the, like, thousands of different application, and it affects people in a really bad way, right? It depends on the sensitivity of the data, and stuff like that. So it's the database is always a very crucial part in any software because of that. Now, in order to avoid such kind of issues, while we design the database itself, we should think of all the different possible scenarios, the sensitivity and the importance of the data, and we have to plan for it. And RDBMS, of course, has that limitation, because when the RDBMS was designed, the other things which was required for that was not wide enough, right? The internet was not as good as it is today. In fact, the internet was not even there when the initial the DBMS was designed, right? So stuff like that. So this is a brief history of like how the NoSQL database came into existence. So now, when I talked about all these things, few of these points might have went over your head, but don't worry, I'll cover that thing in the next coming slides. So just wanted to give a little hint of what NoSQL databases are capable of, and where it is being used, right? So now let's move further. So let's look into this, some of the features of NoSQL database. Of course, NoSQL has a lot of different features, but out of these, I just listed a couple of points, which makes NoSQL stand out from other databases, and which is kind of important for this discussion, for considerations, right? Now, if you look at here, there are 5 points, right? First thing is multimodel. Now, what does multimodel mean, right? The whenever you first of all, what is model in the first place, right? Then we will come to multimodel. Model in general it's just a representation of an entity, right? You want to, let us say that you want to build a software for college management. in which students are the entities, then department is an entity, and stuff like that. And all those things you need to design. Even for the student, let's say that you want to represent his uh, okay, which course he enrolled into, or what is his address, where he resides, what is his age, stuff like that, right? So there are a lot of attributes associated to that entity, and there is also a relationship that basically forms, like if there is a student and there is an address. So this student resides in this address is a relationship between the student and the address. Now, if this students enrolled to a particular course is also a relationship. Now, all these things combined together, you will create something called a schema, right? You create something called a table to represent a specific entity. Then you make a relationship with that by creating a foreign key and stuff like that, right? So that's what you do in a traditional RDBMS. So this is what this schema is what we call as a model, right? So the entity that you define is basically a model. Now, in RDBMS, what happens is that your schema is very tightly bound. Like once you define your model, you cannot change it, right? You can, of course, you can enhance it, but you don't have the flexibility to, support multiple different model for the same entity, right? That is where it becomes challenging. That's what is the limitation of the SQL server, and that's what is been taken care in NoSQL databases. Okay, so it supports something called a multimodel, where a same set of entities can be represented in a multiple different models. So, and we will learn a little bit more about that in the next couple of slides. And the second point that I want to discuss is about the distributed, right? The distributed features of NoSQL. Of course, when I say distributed, it means about like it talks about how a same data is being replicated across different regions. Like as I mentioned about the natural disaster, such kind of situations, you have to be prepared for it. And not only for that, it's also about the availability. Like there might be a temporary glitch. It may not be as big as the disaster, but there might be a temporary glitch in your network or something like that. When that happens, still you don't want your service to be unavailable, right? You definitely want to be get served. Your software should still work, even some of the network related, which is nearby in that region, is affected. And in order to support such kind of a feature, you definitely need your database to be replicated, and that replication has to be handled somewhere somehow, right? So that nature of the database is called distributed. So this is a NoSQL always supports the distributed model. It does not mean that the SQL or RDBMS does not support distributed. Of course, it also supports, but the flexibility and the speed at which this NoSQL works is not at all comparable to RDBMS. So that's the reason I have highlighted that point. So third point is flexible schema. This is very much similar to the very first point that I mentioned regarding the multi-model. So here, as I mentioned, so you won't be able to, you know, uh, represent a different schema for the same entity in RDBMS, but you can do that in a NoSQL database. So you will see that in the exam, like you will get to learn that in the example very easily. So I'll show that in the next slides. Then the fourth point I would like to mention is eliminated downtime. Of course, so downtime eliminated of a downtime is very relatable to the distributed feature of NoSQL, where the downtime elimination can happen because of the the distributed setup that we have for NoSQL database. And high scalability again means is very much related to the distributed feature, where a same like depending on the load, we can actually scale the service to a dynamic level, right? So for example, today for your software you have about 1 lakh users. It is well and good, working fine, all good, but you have already reached your capacity, right? Now if you get let's say another 1,000 user, 2,000 user, your server is exhausted, right? It can't serve any more requests, and that is when you need to what do you say, increase the capability of that server. Now, how do you increase the capability? There is two approaches. Either you scale it vertically or you scale it horizontally. So this is called as scaling. So vertical scaling means increasing the capacity of the same server. Let's say that you are using 100 GB of RAM and some 30 cores or 50 cores of a single node machine. Right, that kind of a setup you have. Now, vertical scaling means that you, depending on, let us say that okay, your RAM is not sufficient to serve this one, so the RAM is a bottleneck here. So you need to increase your RAM. Now you just increase your RAM, or you just increase your CPU capability, or you add more cores. Right? If you do that kind of an upgradation, it is called vertical scaling. Now, it's not easy to do a vertical scaling in a physical system, right? Unless you bring the system down. If you want to upgrade your RAM of that system, of course, you need to shut down the system in the first place. And that means there is a downtime for the user, but you don't want that to happen, right? So what you need is a horizontal scaling for that. Now, horizontal scaling means that you bring another server and you also install the same software out there. Now, if it's a simple software, it can work fine, just like that. But this is a database, right? Just because you brought another database out there, that does not mean that it has all the data that is there in the first server. So, in order to do that, you, of course, your system has to support it in a way that okay, even if the new server comes, the data that is there in the first server gets replicated out there very quickly and starts serving it out. Right now, these kind of things can be done very easily with NoSQL database, and that's the reason. Again, this is one of the point or very highly considerable point for the NoSQL features. Right. So these are some of the key features. Do you have any questions before I proceed further? Okay. So if there is no question, we'll proceed further. Now, the next thing is what is JSON and why it is important. Have you heard of JSON? Can someone tell me what is JSON? No one? Okay. So JSON stands for JavaScript Object Notation. And why it is important in the context of NoSQL, right? You might be wondering. So the JSON is a very similar to XML in terms of its why it is used, right? So I'm hoping that you people are already aware what is XML at least. Right? And XML is a way in which we can represent the data in a way in something called nodes. Right? You can have a top node. That node can have properties. It has some key and value. Inside that node, you can have another node which can again have key and value. It is called attributes. So likewise, you can have can have an entire document like that. It's called XML. Now JSON is a very similar to that, but its format is little different. Right? It here what it takes is basically, if you know JavaScript, its structure is very similar to JavaScript object, but that object is enclosed with a single quote or a double quote. I think most probably it's a double quote keys, right? So with keys and values, so everything is enclosed in double quotes, and that is called a JSON document. Now, this document is very important to understand because many of the NoSQL databases mainly rely on JSON documents. And these documents are very easy to manipulate, comparatively, because especially if you use a language which is very similar to JavaScript or stuff like that, it comes naturally to process that kind of a data. Right? We will see a little bit more about this in in a couple of next sessions. But before that, I would just like to show you how this JSON object looks like, right? So let me just open browser's console here so that we will quickly create one simple object. Okay, let's say that student. I just want to create a student with the ID 10 and name equal to Naveen, right? So this is a JavaScript object. Now, this JavaScript object, if I represent in the JSON format, this is how it will look. So I'm just using a JavaScript function here called JSON.stringify to create a JSON document. Now, if you look at this one, this is a very, very simple JSON document. It doesn't have much things. So I'll just show that. I'll put that here in this a simple tool called JSON Editor Online. We can see this. Right? This is the JSON structure here, right? So you can see there is open curly brace, closing curly brace. In between, you can see there is an ID value, and all both the IDs and values are enclosed with double quotes, except for 10. Why? Because 10 is a number, and for number we doesn't enclose. So only for numbers we doesn't enclose double quotes in JSON, but for others we do. And you can expand it into any level. For example, if I want an address, I can do like this. Okay, I have an address. So that address is an object again. And this address, I can have, let us say, street number. Street number. Okay. So this is one of the sub-property in that. Let us say like this. And I also want to have a pin code here. Okay. Or line number 1, line number 2, something like that. So in this case, let us say I want to have a pin code. Now this is a simple JSON document which has an ID, name, and address can have sub properties, street number, and pin code in this example. Now this is how you write a simple document. Now this document is very easy to manipulate, right? If you use a JavaScript language like JavaScript or anything which can easily parse JSON, even by taking a quick look at it, you will be able to understand, okay, what this data is about, right? You'll be able to reason about the object very easily with this kind of a structure. And it is used heavily in NoSQL databases. We'll see that in a couple of more examples going forward. So, the next topic that I would like to cover is basically what are different types of NoSQL databases. Okay, so this is a very important, very important distinction, because unlike SQL databases, you don't have many similarities. Like if you are, for example, if you are someone who worked with MySQL for about 2 year, 3 year, now you want to jump into another database like Oracle, it's not difficult for you to switch like that. Or you worked leave the years. Even if you just look at start learning MySQL and then you go to MS SQL Server or you go to Oracle or stuff like that. So most of these RDBMS work in a very, very similar way. Okay, it's just that you see some performance difference, some the tooling difference, and some minor syntax difference, right? These are the only things that you would see in different SQL database providers. But it's not the case with NoSQL database, because NoSQL database are mostly purpose built, meaning for each database, NoSQL database type has a different purpose for it. It's not like you create, okay, let's say that, okay, I'm an expert in graph-based database. Whatever the project comes in, I will use graph database. No, it doesn't work that way, because these databases are purpose-built. You will have a lot of benefits in this. At the same time, you also have a lot of downsides as well. So you should be very much aware of what is the pros and what is the cons, and you have to make an informed decision on which database you would like to use. And there might be situations where you may need more than one NoSQL database to satisfy your scenario. So you will understand this as you dive little deeper into the concepts. So first we will cover what are the different types of NoSQL databases available at high level. Okay. So as you can see in this example, mainly the NoSQL databases can be divided into four types. First one is a key value pair, like key value store. Second one is a column family. Fourth one is a graph. The third one is a graph, and fourth one is a document. Right. So these are like four different types of NoSQL databases. I think I'll talk about this little bit in detail with example in the coming slides. Uh, so far, like before I proceed further, do you have any questions? Okay. So now we will see some of the examples, right? Okay. So you can see here key value store. Right? For the key value store, there are two databases shown here. One is Redis and React. These are the two databases available in the industry for a key value type of database. We will see that in an example in a while. Wide column store. For this kind of database, we have HBase or Cassandra. Document store, for which we have MongoDB or CouchDB. Graph store, for which we have Neo4j.s and Infinite Graph. So these are some of the examples. There are definitely a lot more. I just highlighted what is the most famous one, right, in the each category. So, excuse me. So this is an example for a key value store, right? In the right side, you can see what are the top ranked websites in this kind of a model. The first one is Redis, and second one is React. So now Redis is basically a key value store database, but most importantly, it works uh, you know in RAM, right? Unlike any other database, its primary storage is RAM, not hard disk. So because of which the usage of this mainly varies in terms of you can clearly understand that, okay, and that means it is definitely performance wise there is no match. It works really fast, but when it comes to the persistence, I mean, that is where it lacks, right? Because it works primarily with RAM. But that does not mean that all the key value stores works in the RAM. No, for example, even for that matter, React is not like that. It actually stores in disk. Now if you can see the key value store, just an example, uh, you can see that there is a particular key. The value for that is a JSON document in this case, right? And this is the reason why I wanted to introduce, excuse me. So this is the reason why I wanted to introduce a JSON document in the first place. So you can see that there is a particular key, and that key is pointing to a specific document. Now, if this key is meant for a student ID, then you have that entire student record here, which you can retrieve. So you can use key value for this purpose. And it's also possible that for the same key, you don't have a real big object, but you only have a simple string representation of it. So you can just represent it as a string in this case. And you have another key for which it points to a document. You have another key which is points to a specific number, right? So this is how a key value store works. It's a very simple dictionary like structure where you look for a key and you get the value. Now, uh, at the high level, when you look at, so because this is just a simplest example that I mentioned here, but when you really look into the database, it goes beyond this. Okay, so when I say key value, it does not simply mean that there is one key and one value. It's not like that. It also supports multiple different data structures within the within this key value kind of representation. Okay, so now how exactly that works? What are the things that you can do? How like uh, what is its total capacity and stuff like that? It's not in the scope of this talk today, but definitely you can learn about it. Now, as you can see, at least with this kind of databases, you can it's very clear that the schema is not bound here, right? Because for one key, the structure is different, the schema is different, and for another key, the structure is different, right? And even for the sake, if you consider this one, the field here is name and age, but the field here is name and profession, right? It's not like that in a SQL database. If you have a table student, then all the rows within the table should have same schema, right? If it has ID and age, you have ID and age for all the records. But here it is not like that. Each record will can have its own structure. It can have its own schema, and that's how it is represented. So uh, the use case for this is basically you want to have a very quick or a fast performing database which is schema bound, I mean schema less, and you want to have kind of a control in which you know you would like to uh, deal with the data which does not have much of relationships. And if relationship is a very much important part to you, and including the consistency, then RDBMS is definitely the solution. So we'll come to that the point in a while, why RDBMS is still used in the industry, and why sometimes a single NoSQL database may not be sufficient to satisfy all of your scenarios. So this was just an example for a key value pair. Now uh, I'm going to another example, which is a wide column store example. Now for the wide column kind of a database, the one which is famous in the market is Apache's HBase, which is open source, and Cassandra. Right. So these are the two databases which are again very famous for wide column based data stores. Interestingly, you can I have just put some visualization here so that you can clearly make out in your mind how wide column works. So in wide column, now think that okay, this is the data. Okay, so this is just for an representation purpose. So let us say you have an ID one, you have an ID two, you have an ID three, and for ID one you have a country US, JP, and again of course this data is repeated here, right? So I have a timestamp and I have a message for it. So now each data, I have data here, and few of this data is duplicated, right? That means if you think this one in a pure SQL terms, that means you have a table, but this table is not normalized, right? If this table is normalized with the Boyce code 1, 2, 3, or any kind of normalization technique that you apply, eh, that the you will not see data duplications here, right, in RDBMS. But that's not the case with NoSQL. You will see a lot of data duplication here because again, as I mentioned, so this is a purpose built. It depends on what you want to achieve, right? And especially you have a requirement where you want to bring all your related data to get together in a very frequent manner. Now, if that being the case, if you go for an SQL database, what happens is that you need to, if you represent your data in a normalized way, like your student resides in one table, your address resides in another table. Again, the pin code of the address resides in one more table. Again, country resides in one more table, state resides in one more table. Now, if we want to retrieve a student record with his entire address, and you need to display this very frequently in your websites and stuff like that, what you need to do is every time for every particular student, you need to do the joins between all these tables and need to retrieve. Now, if imagine you have millions of records, right? It takes significantly longer to do that kind of a join and give the data for you. Especially if you don't do the right indexing, the application is completely gone now, right? So that's the level of data I'm talking about. So now, for such kind of a scenario, like if you use a wide column store database, what happens here is that, of course, in terms of storage, there is a data duplication, but what you will get is a really high performance. Right now, you see how this data is internally represented in a wide column database. You can see that this particular example here, the key one is highlighted because the key one in the sense the ID and the country is used as a partition key. So because of which you will see this one colon JP here, because it is used as a one is used as a partition key. That's the reason you see this one here, and JP is used as a row key. So the combination of it with the timestamp will give a unique record. Okay, so in this example, you can see this key one, this record, all the related data is together. So I have this JP, this timestamp is data. I have another record which is with US and it's with the timestamp and it's data. Another record with its data, right? And key to another record with its data. So likewise, all the data is internally represented in the wide column database. So because of which, if I am specifying, if I want to retrieve a particular record, let us say this guy, right, key one who resides in US, immediately I will get all the records. So this is just an example. So you will see dot dot dot, but you get the entire data of that particular this one in a very single hit, right? And that is a huge performance improvement that you made just by changing the way how you have stored your data. Now, there are a lot of different features available in wide column database, like similar to Redis, as I mentioned in the key value store. There are a lot of different data structures that internet supports. Similarly, even in wide column databases, it has a singular columnar and single family, multifamily, family within family. So there are a lot of different levels and structures that you can create, that you will learn that individually when you look for the Apaches, HBase or Cassandra, right? I will not go into the further details of this. Again, it's out of scope for this talk. But of course, you can learn these things once you dive deep into these individual databases. And third one is a MongoDB or CouchDB. So this is a document type of a database. Okay, this is again, as you can see, this is very similar to JSON, right? Or in fact, it's a JSON document. Now, document store is one of the very widely used NoSQL database in the industry because of its nature, right? It's easy to see, manipulate, and stuff like that. And MongoDB is one of the very famous NoSQL database. So if you want to start with NoSQL databases, I highly recommend you can start with MongoDB. Okay, this is one of the easiest to begin with, and it provides a lot of flexibility, and there is a lot of demand as well in the market for MongoDB. Okay, and another, if I give my second rank, and I would give it for Redis. Redis is comparatively easy to learn. There is not much complexity. You can quickly grasp the concepts of Redis, and it is widely used for caching purpose. But it's not limited to caching, but mainly it's used for caching purpose. So MongoDB and Redis is something I highly recommend. If you want to start, definitely this is the thing that you would like to give a try. And third one is HBase or Cassandra. Either one would work. So now coming to document store, like as you can see, the entire document is represented in the JSON format. Here you can see there is a student, there is an address. The student's address is represented together. Like here also, like if I want to retrieve an individual student, the student record along with the address can be retrieved very quickly because all the related data is stored together as a single document. But again, because of this kind of a structure, there will be data duplication, right? Now, in if you go for a RDBMS, what you would do, for example, city and state, you don't want to repeat city and state because in the same city, so many different students reside, right? And in the same state, so many students reside. So you can simply have one-to-many relationship in a RDBMS, and you can save a lot of space. Again, the intention here is not to save the space. So if you go for this kind of database, you will definitely have a data duplication. That also means there is if you want to go for some sort of an updation, you will have challenges to maintain the consistency. Right? This is the downside of it. For example, there is a spelling mistake in the city that you wrote. Now there is already millions of records which is there in the database. Now if we want to update the city this one, if it is an RDBMS, you just update that city and everything will still work as is because you just join and get the data. But here it is not like that. That city is actually duplicated in all the millions of records. So now if that update operation becomes really costly because you have to retrieve each and every individual document. You need to update it and store it back there. So this becomes a challenge. So that's the reason it's very important that whenever you make your decision to go for a NoSQL database, you should really understand its pros and cons. Then only you should go for it, right? And if you really understand the concept right and use the right database, it gives you significantly, good in terms of performance, in terms of availability, in terms of fault tolerance and stuff like that. Right. So this is about a document store. So similarly, there is one more type which is graph-based database. The one which is very famous for this is Neo4j, and infinite graph is again one more. Neo4j is something is very widely used. Now this kind of a database is works very similar to your trees or those kind of data structures, right? Where there will be something like nodes and there is something like edges, right? So here in this case, this person is a node and product is a node. Again, this person is a node. This person is, so all the individual person that you see is a node. Even the product is also considered as node, and the relationship between the this person and the product is maintained in as a edge, right? So these all are called as edges. So now both the node and edges can have its own properties. Okay, that means in this example you don't see it. It's just that you'll see some kind of a flow, like okay, this person has purchased this product, this person also purchased this product, and this person knows this person and stuff like that. Okay, so now how this is possible? Because this is a, as I mentioned, each person is a node here, and each product uh, is also a node, and this person did what is represented in its edges. Now, when you connect the edge to the nodes, you will actually get a relationship, right? And that's what, so it is used for all such kind of a use cases, especially in e-commerce sites, like you want to identify okay, a particular person is browsing a particular product, right? And you want to suggest that the people who brought this product has also brought these other products, or the person who did this also did kind of this kind of stuff, right? So those kind of recommendation you would like to give. Now when you have millions and millions of records, and if you want to give such kind of a recommendation, of course you need to, that system should be aware of users behavior and stuff like that, right? Now for that recommendation system alone, you can use this kind of database to represent, because each time an entity performs some action, you keep on adding the edges for it, right? And you substitute the nodes, you add the edges. So likewise, you can easily build this kind of graph, and you can give some intelligent suggestion and stuff like that to actually boost the customer confidence, stuff like that. Now this is one of the example I mentioned. It has a lot of other use cases. If you want to build a road related, this one security related stuff, so many different use cases. It depends on what you want to achieve. So you can actually go for such kind of a database. Again, Neo4j is one of the very famous in this kind of data store. Now, provided all these, the thing is, why RDBMS is still around? I think by now you might have already got why RDBMS is still around. I think I mentioned this a couple of times in my talk. So basically, in all these scenarios, every individual database type, they have their own place, right? And similarly, RDBMS also has its own space, and of course, it has a dominant space. Now there are two reasons. First of all, RDBMS is very widely used. There is used, and there are so many existing softwares which is written in like using RDBMS with the help of RDBMS. It's not easy to migrate such things so quickly to any of the other databases. That is one of the reason why they still exist, right? But that's not the only reason. The most important reason, another reason, is that it still works. It works perfectly fine for really large and reasonable number of data. The RDBMS becomes a bottleneck or the problem only if you have really huge data, what we categorize as big data, right? You might have heard this jargon word big data so many times in different articles and stuff like that. So big data is where you need, there is a real need for a NoSQL, but otherwise you don't really need it. If your data is really really big, that means there might be situations where RDBMS may not be able to handle it elegantly in terms of performance, in terms of update operations, in terms of scalability, in terms of availability and stuff like that. So whenever there is a need for such kind of a situation and stuff, that is when you really go for NoSQL. But otherwise, RDBMS is still good. There, even from the career opportunities, there are still a lot of career opportunity is available with RDBMS. So if you learn RDBMS, there is definitely no harm, and there is a lot of opportunities available. But on top of that, if you, for your profile, if you add at least one or two of the NoSQL databases, then trust me, your profile will definitely get boosted at least 20 to 30 time, percentage, right? So that is the like added advantage that you get as you add some NoSQL database to your profile. So now, how you can begin with it, right? What are the different platforms available, or how you can get started, or what I personally I would recommend you to do is these things. As you can see here, there are a couple of databases. Now you might be wondering, I talked about all different databases. I have shown all different examples. Now in the final slide, when you need to begin, I'm showing entirely different thing. Well, it's not like that. Definitely, it's different. Okay, there is a thing that you need to understand, that there is nowadays the companies go for something called a cloud native applications. Now, what do I mean by cloud native applications? Right, so the meaning of the cloud nativeness is that uh, you build an application, that entire application from like resides in the cloud itself. It does not even come out of the cloud, meaning you can't really have that kind of a database in a simple individual systems, right? These systems can reside actually in the resides only in certain cloud providers, right? So for example, Microsoft has its cloud called Azure, and most of, like, if you're going for a cloud native kind of an application development, then this application always resides in Azure itself. They does not even come out of the Azure environment. Now if that being the case, of course the NoSQL databases which is available in that cloud becomes the first choice for that, right? And if you are going for a Microsoft cloud, then of course Azure is a Microsoft cloud, and then I highly recommend you go for Cosmos DB, right? Now, Cosmos DB is again a NoSQL data base provided by Microsoft. It supports multiple different schemas. Okay, it supports both all of these things. It supports your key value. It supports white column. It supports document. It even supports graph. So what happens with this is that if you learn Cosmos, that means you internally learn all those, like along with the Cosmos, you also learn all those individuals, and you will also learn about the its distributedness, its consistency, handling, the way how its consistency is handled, how you deal with fault tolerance, and stuff like that, right? So all these things you will learn along with that. So I highly recommend that you start something with this kind of cloud native related NoSQL databases, so that even companies will look for it. Okay, so it definitely adds a lot of value, and you will get a lot of courses as well on these kind of databases, because all these individual companies will promote their own stuff out there. But that does not mean that okay, this is the only thing where you can start. Of course, you can individually go for these databases like Redis, React, HBase, Cassandra, Mongo, Couch, Neo4j. Right? You can definitely go for that individuals, but Cosmos DB is something still you can start. So similarly, AWS provides the DynamoDB, which is also a NoSQL, but it's provided by AWS. All the companies who use AWS for their cloud is likely to use DynamoDB in the future. Even currently they use. And Google has two different solutions. It has a cloud data store, and it also has Bigtable. uh, I don't have much idea on the both of these databases, but I heard Bigtable is something which is really booming in the industry. Many people use that for different stuff. Even Google internally uses that for a lot of different things. And similarly, even Cosmos, for that matter, from Microsoft, they also use Cosmos DB a lot like internally. Uh, Even from what I am aware, the Cosmos DB was actually developed in around 2009 in Microsoft, and it was all used internally till 2015 or 16, and that is when they made it public. It made available for public usage. So even I have used it internally at Microsoft at around 2013 or 14. It was working really nice, and definitely this is something you can try it out. Right. So that's all I had for my talk. So if you guys have any questions, it's time for it. Please ask. I'm here to answer. And if you're not comfortable asking here, you can always ask in our Skill House forum, which is forum.skill-house.com. You can always visit there and post any questions. Either me or anyone from our team, or it's like a community. Anyone who participate or register in Skill House can contribute out there. Even if you know the answer, you're free to answer it. So if you have any questions, please shoot me out.